part 2 of lesson 2's video, and we'll jump straight into it, and we're looking at adjacency matrices. So this isn't something you have not seen before. Whenever we get a graph of some sort that has towns or connections and we want to establish a matrix with this, this can be done through a series of zeros and ones. As a little indication, we've got I'm going to put these words from and to, just for consistency's sake. It doesn't make any difference where it goes from and to, but I just like to be consistent with this. So instead of reading all of this, I'm just going to jump straight into this example. We've got 4 towns, A, B, C, and D, and if a town is connected to another town, so from A to say B, we can see that there is a line that goes to this town. We have this 1 that indicates that it goes from A to B. So from A, over here to B, there is a 1. Meaning from B to A, we're also expecting a 1. From B to A, we're also expecting a 1, because these connections are 2 ways. Now the thing that's different, slightly different, is that there could be more than 1 way to go to a town. So in this example here, we've got A. Not only is there 1, but there's 2 different links that we can go from A to D. So in this case, we don't actually write a 1, but we actually write a 2. So from D to A, right this way as well, or from A to D, there is this number 2. And there could be multiple ways that can go from one town to another. However many links or ways there are, just directly to that town, we will put the number associated with this. Now, usually you're used to a diagonal of zeros, but you'll notice that within this diagonal, there is this 1 here. So from C to C, and this is because there is a link that goes from C to C. Now, some people assume that because there are 2 ways to go into C, that technically a loop should be a 2. But in this case, there's 1 in this C area from C to C. So this is to indicate that there's 1 edge that connects to that vertex. So this is 1 edge. This is just 1 edge, so we put 1 there. So just remember that loops is equal to 1 and not 2. Common misconception that I do see. But it's pretty straightforward if you want to see these connections, to put a graph to an adjacency matrix. So what we're going to do is we're going to represent the following network with an adjacency matrix. So this is going to be a 4x4, and I know this because there are 4 different towns. A, B, C, D, A, B, C, D. And this is from, and this is to. Alright, so A to A, there is a link, there's a loop, we'll put a 1 here. From A to B, there's only 1 way. From A to C, there's no direct link from A to C, 0. And from A to D, 0. Alright, from B to A, there's that 1, we're expecting that because from A to B there's also a 1. From B to B, there's no loop, so there's a 0. From B to C, there's 1. And from B to D, 0. C to A, no direct link, 0. C to B, there's 1. C to C, no loop, 0. And C to D, 0. And with D, because D is this Lone Ranger, I'm expecting zeros all across. And that's all there is to that for that one. And in example 5, which is the last example, we're going to construct a graph for the following adjacency matrix. So we've got these 3 towns, so we'll put town A, town B, and town C. So from A to A, there is a 1, so that indicates that there is a loop. So we'll just put a loop like that. From A to B, there's also a link. A to B, there's a link. And then from A to C, there's also a link. Here we go, so that's done. B to A, we've already got that link that we expected, so that's done. B to B, there's no loop, yep. And then B to C, there's a link. That's done. And then technically this one should already be done. C to A, there's a link. C to B, there's a link. And there's no loop for C. So that's that one done. Very simple, straight to the point. And this concludes this lesson for lesson 2. Go ahead and check your log sheet, see which questions you need to do, and I'll see you in the next video. Bye bye.